this is the official start of CS40 for today. Let's see. So we have a homework assignment that is due tomorrow with the Reddit bots. So at this point, hopefully things are mostly chugging along good, and your bots are all out there talking to each other. I've seen there's quite a few submissions and posts on the subreddit right now, so I'm very happy with that. Last time we talked a little bit about let's see. So yeah, with the Reddit bots, we were using the Reddit API to actually extract information and interact with the Reddit website. And then last week we talked about web scraping a little bit more generally with what if there's a web page like eBay where there is no API for using it. Today we're going to, really for the rest of this course, we're going to be switching gears back to the creating aspect of web pages. And we saw in the very beginning with HTML how you create what are called static web pages. So using just HTML to display something. And these are great for like when you have content to display that is static, that doesn't change. So like a blog is a great thing to just write with HTML. But there's a lot of web pages, often called like Web 2.0 sites, that are much more interactive. So social media websites are sort of like the key example for these. And these websites, so like we've seen with Reddit, let you create posts, let you write comments, interact with other people on the web page. And the remainder of this semester, we have about 3.5 weeks left. We're going to actually talk about how do you create your own interactive web page like this. And our sort of motivating running example is going to be Twitter this time. You all are going to create your own actual Twitter web page that other people can come to, create accounts, send messages to each other, and it's not going to be nearly as sophisticated as Twitter, but it'll have all of the sort of basic features. There's two sort of new concepts that we're going to cover in order to do this. The first one is called databases. And databases are a convenient way to store lots of data. They're the back end of all websites, whether it's Reddit, Twitter, Google, Facebook, any of these dynamic websites, they all have some sort of database in the back end. And all of these databases use a special programming language to interact with them called SQL. And so this week we're going to be going over how to use this SQL programming language and how to use it to store data. Then next week, what we're going to start talking about is a Python library called Flask, which is the library that actually lets you create these dynamic web pages. And with this Flask library, we will sort of be connecting to your SQL database, and that's how the information from this week comes up. So I'm going to share my screen. And right here we have, so the week 10 website for this week. And there's 5 in particular commands with SQL that we're going to be covering today. And we'll see just sort of at a high level idea how they work. The particular database that we're going to be using is called SQLite 3. And this database is built into Python. So there's nothing that you have to download. Today, though, we're not going to be interacting using the Python version at all. We're going to be directly using this SQLite 3 database. And the important thing from today is just sort of following along at a big picture level, getting the motivation for what we're talking about, high level idea of how things work. And then Wednesday, we're going to combine the things that we talk about today with Python. If you do want to, say after lecture is over, follow along like in particular step-by-step with the things that we're going to be talking about today, I'm going to be using a program called SQLite 3, which you can download from this website right here. It shows instructions for whether you're using Windows or Mac and all the different versions. But this is an entirely optional task. If the things that we're talking about today seem fairly confusing, then I do recommend doing this optional task and then recreating the steps that we're going to do today. Otherwise, if the things that we're doing today seem like mostly making sense, then you'll be in a good spot for Wednesday when we combine this with Python.
Will we have a lab or a quiz this week?
Great question. So quiz, no quiz this week. Next week you will have a quiz about all of these SQL commands, but I want to make sure that you have a week's worth of exposure to them before having the quiz. And we will have a lab this week. The lab is related to the Python interacting with SQL, so I'll have that posted after Wednesday's lecture. Great question. Any other questions so far? Okay, one last thing to point out. So the language that we're using is called SQL. This is how it's written out though. It's written out as SQL. And one of the ways that I can tell whether somebody is sort of like an more experienced data scientist or a more junior data scientist or computer programmer is how they pronounce this word. That if you go around telling people you're programming in SQL, that's a sign that you're not like in the community, you're not interacting with other people. All the people who are sort of using this on a daily basis to get stuff done, whether they're at like Facebook, Google, Twitter, working on the back ends of those projects, or whether they're at a more like data analysis company analyzing whatever data, they all pronounce it SQL. So SQL is how this is pronounced and how you should pronounce it in order to make everybody else think that you know what you're talking about. Okay, so before actually talking about these SQL commands, I want to give us a high-level overview of like what SQL does. And the way to think about SQL is you should think about it as a spreadsheet. So here I have a spreadsheet open. I use a spreadsheet called LibreOffice. It's just an open source spreadsheet, very similar to Excel or Google Docs. And there's on the top up here, I have some column names. And this particular table right here, we'll be calling each of these sort of sets of information that we're working with, we'll call them tables. This table is called the users table. And I know it's called the users table because of this tab down here. I also have a table called messages over here. And with this table of users and messages, that turns out you'll be able to store all the information that you'll need for your next assignment for implementing a Twitter web page. In the users table, each user will correspond to an individual row. That this top row is like the names of what each of these columns mean, and then each row is an individual user. So on our this little Twitter example that we're starting with right now, there's 3 users, Trump and Biden and Evan. Evan is the name of my son. Evan is 2 years old, and then Trump and Biden are both much older. And each one of these users has a username that they could use to log into the web page with. They also have an age, and they also have a user ID. In SQL, it's sort of customary for every one of these tables to have an ID, which is just an integer, and it'll start at 0, and then each other item in the table will add 1. And so if I wanted to add another user here, I have to increase the ID to 3, and let's create one for me. Let's say Mike, and my age is 35. Down over here, we have so this is the messages table. And here we have the ID. And again, this ID corresponds to the ID of the particular message. And the ID right here always is going to start at 0 and increment by 1 each time, 0, 1, and 2. Here we have what I'm calling the sender ID, and this is the ID of the person who sent the message. So this message right here, message ID 0, was sent by sender ID 2. And the way I know which user that corresponds to is that I would look in the users table, find the ID of 0, or sorry, find the ID of 2, because that's what the value was, sender ID 2, and that corresponds to Evan. And so the message that they sent was, I am a baby. And the time that they sent that message, or the time that they created that message, was 2:30 today. Here we also have 2 other messages that were sent. All of these messages have the same content. They all say, I am a baby. And then the sender ID, though, is different for each of those. We have a 2, a 0, and a 1. And looking back over at the username, we have the 0 corresponds to Trump and the 1 corresponds to Biden. So this one would be Trump sending a message saying, I'm a baby, and this one would be Biden sending a message saying, I am a baby. I could add a new message to this table by doing something like putting a 3 here. And now this will make Evan send this message as well. So another 2 right here. I know this is Evan because 2 in the ID for users corresponds to Evan. And he will say, I'm actually a toddler. And this message will be created at, what time is it right now? 42. And then the whole goal of this SQL programming language is to help us sort of manipulate these tables, to add new rows into these tables, or to figure out, say, if I want to find all messages created on a certain day, how do I get all of those messages? Or if I want to get all of the messages sent by a particular user, how do I get those messages? Or if I want to find all of the users who are, say, minors, how do I get those users? Answering these potentially very complicated questions about our data sets that's represented in these tables. Before we talk about how to actually do that in SQL, are there any questions about this sort of model of representing data? Sometimes we call this the relational model of data when we store data in tables that contains rows and columns. Are there any questions about this? Okay. Then I'm going to switch over to VS Code, and we'll start talking about about how to actually represent that data in code instead of in Excel. So for the SQL programming language, right here in monday.sql, I have a simple example SQL file. And there's a couple of things that I want to highlight about this. The first is that comments in SQL start with the dash dash. So this is a comment, and this is a comment. These are not comments. In Python, we used the hashtag. This is a comment in Python, but this is not a comment in SQL, and this will generate an error message. So you always put the dash dash for comments in SQL. The second thing is that the SQL files always end in .sql. That's how you know that a file is a SQL file instead of a Python file or an HTML or any of these other languages. And then these down here, let's talk about these particular commands. So there's going to be 5 commands that we look at today. The first of these commands are the create command and the insert command. And what this create command does is it creates one of these tables that we're going to be looking at. So that create command creates this users table right here. And this table has an ID, a username, and an age. And oops, right here, say create table users. We have an ID, it's going to be an integer. We have a username, it's going to have some text in it, and we have an age that's also going to be an integer. So this line right here creates the spreadsheet for us. Then these 3 lines down here are what's going to actually insert the values into that spreadsheet. So create creates the spreadsheet, insert adds information into the spreadsheet. And we know which particular spreadsheet, which table we're adding into, because this name right here has to correspond with the name of the table. And then this part is a little bit confusing at first because it's kind of redundant. But inside of these parentheses right here, you notice that I have ID, username, age, and age. These are just the names of the columns that I'm going to be inserting into. So in the first parentheses is the names of the columns. And then in the second parentheses over here is the values of the columns that I'm going to be adding. So here I have 0, Trump, and 74, because in my table right here, I have 0, Trump, and 74. And then 1, Biden, 77, 2, Evan, and 2, like that. So the second set of parentheses is the actual values. And it's important that these values are in the same order that the column names are in. The reason why you have to specify these column names is because you can actually put these in a different order and it'll still work. Okay, so I'm going to save this, and now we're going to run this file. And we'll see how to run this file through Python again on Wednesday. But right now, just to make things a little bit simpler, I'm going to use the SQLite 3 program directly. And if I run SQLite 3, it opens up this prompt. We would say sometimes that this is opening SQLite in interactive mode, similar to how if we just type Python 3 on the command line, it opens Python in interactive mode. And I know now that I'm in SQLite because down here it tells me SQLite right here. And in order to load this file and see what happens, the command in SQLite is .read and then the name of the file. So .read and then monday.sql. And I'll hit enter and we'll see that there's no output. And so whenever everything works correctly, there's no output from a .sql file. And so this is sort of different than Python because this is just like a constant that running a SQL file will always create no output for you. There's not like a print statement or anything like that that you can use inside of a SQL file. So the next question though is how do I sort of get access to the information in this table? And the next command we'll look at is called a select command. And the select command will let us read the information from this user's table. And so the way this command looks, we'll see a lot of versions of this command throughout the coming weeks. But to start with, we'll do the simplest possible one, and it is select star from users. I'll go ahead and hit enter and we'll see what happens. And we get this output right here. And we see that this output is the same as the output from our Excel file right here. I guess it doesn't have this line right here, but that's because I didn't include it in my insert statements. It has one of these lines for each of these insert statements up here. Are there any questions so far?
So does the star mean like just everything, I guess?
This is a great question. So the question is, what does this star mean? And the answer is right here. This is where you select exactly which columns that you want. So star means get all of the columns. In this case, there is an ID, a username, and an age column. If, say, I only wanted to list the usernames, I could say select username from users. If I wanted both the usernames and the ages, I could say username, comma, age from users. I could also, if I wanted everything, manually list everything out like that. But if I do want everything, it's easier just to say select star from users.
I have a question.
Mm-hmm.
So how do we get like the fourth values that you added on the Excel sheet without like inserting it in the code? Like, can we insert something manually and then get it?
This is a great question. So yeah, the question's over here in the Excel sheet. I added this value right here. And now how do I get access to it in the code? And so the answer is that we must have an insert statement for every line in the table. So if I want to add that piece of data into the database, I must have an insert statement that does it. So I'll copy and paste that down here and change this 2 to a 3, change that to Mike, change this to 35. We'll save that. And notice that, so I've saved this up here, but if I run select star from users, it's not in my database still. I have to close out of SQLite. So plus Control D to close out of SQLite, and then reopen it up. .read monday.sql, and now if I do the select star from users, it will be in there. Yeah, so general principle of working with databases or working with SQL is that if something is in the database, it must have been created with this insert statement. That's the only way to get something into the database. Great question so far. Any other questions? Okay. So the next thing I want us to look at is we're going to look at this ID value in a little bit sort of more care, a little bit more detail. And this ID value, you notice that I'm sort of right now manually adding 1 to it each time that I do this insert statement. But that's kind of a little bit annoying because computers are great at doing automatic stuff for us. Humans suck at doing automatic stuff. We make typos, we make mistakes, but computers love boring, tedious tasks. And so we want to make our database do as much boring, tedious work for us as possible. And so one of those boring, tedious things is updating this number. And the way you can force it to automatically do that is by the syntax saying primary key right here. This ID is called a primary key that is always incrementing by 1. And by putting this syntax right here, primary key, after the word integer, it makes it automatically increment by 1 for us. So now instead of doing these lines right here, let's see, we'll copy that and we'll comment these out so that we can still see the old versions. And let's actually have the new version down here with the old version right here commented out. Down here now, we no longer have to specify this ID. And since we're taking the ID away down here, we have to take it away over here as well in the values. And so this is one of the reasons why we have to specify exactly which columns we're adding over here, is because sometimes we can not necessarily add into all of the columns. And so now if I save that, I'm going to come down here, Control D will get me out of SQLite. I'll rerun it, reload the file, and you can see now it's automatically getting all these values for us. Looks like it's starting at 1 instead of 0 now for us, but that's fine. The important thing about these key values is that none of them are the same as any of the other ones, but we'll never actually care about the particular numbers. Let's see, another sort of feature of SQL is that you don't have to always specify all of these columns. So if we don't specify ID, it will automatically create an ID for us because it's a primary key. But if we don't specify a username, that's also okay. So here, if I only want to just specify an age, like this, that'll be totally okay. There'll be no complaints from SQL. And now when it comes down here, there's just this sort of username that's blank, and it has age 35 because that's what I put right here. Typically though, well, let's see, so this, when we do this, username is what's called a null value. Null meaning there's nothing inside of it. And there's nothing inside of it because we didn't specify what to put inside of it. For a, let's see, a website like Twitter though, we would want every one of our rows in our database to definitely have a username. It would be really bad if somebody added a user, but they didn't have a username. And the way that we call it enforcing this constraint is we say username text not null. Username text not null. And this not null will mean that this will generate an error message. So I'm going to save this, come down here, press Control D to leave out of SQLite, run SQLite, and now when I run this read monday.sql, we get this error on line 22, error message right here. The not null constraint failed, users.username. So SQL is complaining that we can't do this insertion because we've added these two lines right here, or these two words right here. Are there any questions about that? Okay. For a website like Twitter or Reddit or any of these websites, usernames definitely something we want to have not be null, but let's, like an age, maybe we can have it, maybe we don't have it. That's probably something that's okay to allow to be missing. And so here, I'm not going to add the not null because I want it to be okay that age is sometimes missing. And so we'll have username, and then we'll have my wife, and we'll say that she doesn't want her her age to be known, and so we will not pass in an age for there. And so I'll change this comment to age is a null value because age is not specified. So we'll save that, Control D here, SQLite, reread the file. Now there's no error message. We have a null value, there's no age, but it's okay to have no age be added. And so now when I select from users, we get that Kristen has no age, and everybody else has an age. Are there any questions about that? Okay. One of the key vocabulary sort of terms, let's see, so we've seen a number of key vocabulary terms so far. We've seen the primary key vocab term. Every table should have a primary key. So every table should have a primary key. The next key vocabulary word is the null value. Let me make this list of vocab words. A null value is a value that hasn't been entered. And then the next key vocabulary word is a schema. And this, everything in between the parentheses right here on the create table command is called the schema of the table users. So the schema of a table is everything between the parentheses of create table. And whenever you're working with a database, whenever you're working with SQL, SQLite, the most important thing to know about the database is the schema of the tables, because the schema tells you what you're allowed to store in there. Here, a username and an age. And the particular schema is determined by whatever your goals of the project are. So here we're going to create a web page where people can log in and send messages to each other. And so our schema requires that they have a username, but the age is optional. Any questions about that? Okay. So the next command that I want us to look at is, we're going to look a little bit more specifically about this select command. So this gets us all the information in a table. But if we're, say, like Facebook, in Facebook's database, they claim to have around 5 billion user accounts created on Facebook. It's more than half the world's population. And so if we wanted to get information from Facebook's database and we ran a command like this, it would give us 5 billion results back, which is just way too much to process and make sense of. And so we want to somehow filter the results that we get back. And in order to filter the results, what you do is you add what's called a where clause. So where over here, and then you have a condition to the right of the where clause. And the condition is like an if statement. And whenever the condition is satisfied, we will return back the corresponding rows. So if I wanted to say, get all the information about my son, Evan, I could say select star from users where username equals Evan, like this, hit enter, and it only returns the particular row of Evan's properties. If I wanted to get his just his age and nothing else, I could say select age from users where username equals Evan, and it gets just his age. And then if I wanted to change it to say getting Trump's age, like that, and it gets just Trump's age. So over here, this is like an if statement. It's applied to each one of the rows individually. And if the row satisfies the if statement, it will return the result. These if statements only returned, or were only true for one of the particular rows, but it's possible to create these conditions that will be true for many rows. So let's say, let's get all of the adult users on in this table. And so we could say select username from users where age is greater than 18. Hit enter. And now this gives me back Trump and Biden and Mike because all of us have ages that are greater than 18. You notice that it does not give back Evan because his age is less than 18. And it also does not give back Kristen because there's no age specified right here at all. If we change this to select username from users where age is less than 18, it'll give me back Evan, but it will not give me back Kristen. So normally we think of like people are either greater than a certain age or they're going to be less than a certain age. But here we have this third value, this third possibility where they're neither greater than nor equal to the age. If we want to get the people where a particular column is not specified, what you do is you say the name of the column and then is null. And this will give you all of the people where this particular column, whatever you have specified, is equal to null. Are there any questions about this where clause in the select statement? Okay. Yeah, we'll be using, this is probably the most important command that we'll be using over and over and over again, because every time when somebody accesses your Twitter webpage, whether they try to look at a message or they try to log in, we'll always be using a select statement that looks like one of these things. Select some piece of information with an appropriate where condition to actually get that particular value. So we'll be seeing this a lot. The next statement that we're going to look at is called the update statement. And the update statement lets you change your values in the table. So my son Evan, he's true right now, but in January he'll be turning 3. And so when he does, this value will be out of date and we'll have to update it. And the syntax for the update command looks like update users. To update, then the name of the table, then we say set, then the particular columns that we want to set. We'll set the age equals to 3, and then we need a where condition to specify which things we want to update. So where username equals Evan. I'll hit enter, and you notice there's no output that's been shown. But now if I do the select star from users command again, we'll see that Evan's age has updated to 3 instead of 2. If I were to say update user set age equals to 23, where username equals Evan, we'd get 23 right here. And now our select statement about adults, people with age greater than 18, is now going to include Evan as well as all of the other adults. In practice, this is, I mean, it's an important command. Things need to get updated on web pages, but it's not used nearly as much as the insertion or the selection commands. Are there any questions about this?
I have a question. So can we only can do those like select and update in the interactive mode, or we can write it like in a code above the terminal?
Yeah, this is a great question. So the question is about these commands, can they only be used in the interactive mode, or can they be put up here? And in general, or what's common in a .SQL file is to have only create and insertion commands in the SQL file. And it's possible to have, say, an update command right here. We could copy and paste this line up here, and then it would run this line. But if we had this line right here, then it would make more sense probably just to update this directly and say 23 right here, and then we don't even need this update line at all. So in practice, it's in these SQL files, it's only create and insert commands in the file, although it's technically possible to have other commands. There's another great question in the chat right now about, are these changes permanent or will they get reset? And so that's the next thing that we're going to talk about. Let's, right now, if we do the select star from users, because we've run that update command, Evan's age will be set at 23. I'm going to quit out of SQLite, reload into SQLite, and we'll reload the file, monday.sql. It looks like it's not saved, so we'll save that first. Read that. And now if we do select star from users, Evan's name is back to being just 2. So by default, all of these changes are just temporary and not permanent. And so the question is, how do we make them permanent? It's not very useful in particular. It's a little bit useful, but not super useful if we everything has to be in this SQL file. And so the way that we make things permanent is that when when we're running the SQLite 3 command like this, if we specify a file name after the SQLite 3 command, all of our changes will be saved into this file name over here. And so I'll call this file name monday.db. And it's important to get the difference between a .sql and a .db file, get to understand the differences between those two files. So SQL files always contain just SQL commands, but DB files actually contain the result of running SQL commands. So .db files contain the result of running SQL commands. And so these two things are very closely related, but they're slightly different. And so I'm going to illustrate that next. So here we've opened this up, and now if I do the .read of monday.sql, I want you to pay attention over here to the files that we have in the current folder. That you'll notice that there is not any .db file right now. But as soon as I run a command inside of here, it's going to create this .db folder, or this .db file right here. And this .db file is we would sometimes say this is the actual database. So DB files contain the result of running SQL commands, and they are the database. Another way of thinking of SQL files is that they are instructions for creating the database. And now I can do the select star from users, and we see that there's this 2 right here. If I rerun the update command, set Evan's age equal to 23, we have 23 right here. And now when I quit out of SQLite, press Control-D to quit, and I'm going to reload it, specifying this same database over here again, and I hit enter. And now when I do select star, the changes are persistent and they have been saved. So the DB file contains like all of the saved changes. In practice, what's going to happen with our Twitter websites that we're creating is that you'll have a SQL file that will create just the schema for all of the tables that you're going to use. So it'll create a schema for the users and a schema for the messages. But then we'll have a Python program that connects to the DB file, and the Python program will be running these insert commands and these update commands, and they'll be actually modifying this DB file. And when you're running a big website, there's, say, maybe thousands of messages are getting created. None of those messages will be stored in the SQL file. They will be only stored in the .db file. If the difference between these two files isn't 100% clear right now, that's still okay. As we sort of, over the next few lectures, see a bunch of examples, the differences will start becoming sort of second nature.
Mike,
yeah,
can you click on the DB file just so we
Mhm.
can see how it looks like?
Yeah, so the DB file, you'll notice that VS Code says it can't display it because it's not a text file. It doesn't know how to display it. If you click on do you want to open it anyway, you'll see that it just contains a whole bunch of kind of random looking gibberish inside of it. You'll see things inside if you're like, okay, there looks like there's a Trump and a Biden, but there's just gibberish. So that's another difference between the SQL and the DB file is the, sometimes say that the SQL file is human readable and the DB file is only machine readable, not human readable. Great question. Any other questions so far? Okay. Let's see. So the next thing that I want to show you is with this update command. Update is a potentially very dangerous command to use. Let me do it like this. Danger. Update, and we haven't covered this yet, but the delete command are both very dangerous. They can change your database in ways that it's not possible to recover from. And so you have to be very, very careful whenever you're using either of these two commands. And so let's see that in action now with the update command first. Update. So the way that you want to use update is you use update, the name of the table, set, the values you're going to change, where the condition that must be satisfied. But this condition, remember, might match more than one different row. So let's say set age equals to 23, where age is greater than 0. This right here is going to match this row, this row, this row, and this row. And so now when I hit enter, select star from users, now everybody's ages have been totally forgotten about. And once we do this, we've accidentally set all of these ages to 23. There's no way to undo that change. Once you've made a mistake like that, the data is corrupted forever. People who work at, say, like one of these major tech companies, Facebook, Google, Twitter, any of those people, you have to be really, really senior in order to be allowed to use these update and delete commands. So we're talking like vice presidents of the company, because people who, if you don't use these commands correctly, then you'll accidentally delete the whole database. And so when one of the people at let's see, every company has a different policy on exactly how they use these commands, but what's very common is somebody will type in the command and then they're not allowed to hit enter. It has to be somebody totally different who will then come up, read the command, make sure that it does exactly what they want it to do, and then that person will hit enter, just to ensure that the database doesn't get corrupted. Yeah, I personally know of 3 different companies that their business was just wiped out because somebody who wasn't supposed to run these commands accidentally ran these commands and just deleted everything in the database. And so once the information's gone, you can't get it back. Let's see, so in this case though, because we know what the values should be, let's go ahead and run another update command to fix these changes. And so we'll update users, set age equals 74, where username equals Trump, set age equals to 77, where username equals Biden, set age equals to 35, where username equals Mike. And now when we run a select star from users, we're good. Back to the original values. So let's see, the last command that we're going to talk about is the delete command. And the delete command works very similar to the update command. You say delete from users. And so here's the table that we want to delete from. And now we always say where username equals whatever username. So let's say Evan, he's actually too young to be having a Twitter account right now. So the lawyers have gotten involved and said Twitter needs to delete his user account. So they would run a command like this, hit enter, and now select star from users, and he doesn't appear. You'll notice that up here, Evan's ID value used to be 3. And when he's deleted, that gap, there no other value or no other row takes on the ID value of 3. So even though these IDs automatically incremented, once the ID is set to a particular value, it stays at that value for forever. And it's okay now that there's a gap between 2 for Biden and 4 for Mike right here. But that 3 for Evan will never be used again. If we insert a new value, say Evan gets back online and wants to create a new account, insert into users, username, comma, age, values, Evan, comma, 2, and then select star from users. That ID will now be set to 6 and it will not go back to 3. That 3 will never be used again. Are there any questions about the delete or the or anything we've talked about so far? Okay. Then what I want to look at next is, so over here, we've talked about like this one table and a lot of detail so far. But let's talk now about our messages table. And we have, now we'll have these 4 columns. Whoops. We have this ID, and this ID again is the ID for each individual message. This sender ID is not an ID for this table, but this sender ID corresponds to an ID in this table over here. And then we have a message and this created at. And if we want to add all of this information to our database, I'm going to copy it and come back over here, and down here we'll paste it just so that we can see it. The first thing that I need to do whenever I'm adding a new table into the database is to create its schema, run this create table command. So run create table, and then we'll call it messages. And we always have this ID column. It'll always be integer primary key like that. And now we'll have the sender ID. Sender ID will also be an integer. And this sender ID again is going to correspond to this ID from the users. And then we'll have our message, that'll be text, and then created at. And we want the created at to correspond to a time. And in SQL, the way you specify that something is a time is the keyword timestamp. Timestamp will give it a date and a time, and yeah, that time, it's only displayed, I only wrote it out into seconds right here, but it actually stores it out to like microseconds, really, really precise times if you wanted to store them really precisely.
I have a question.
Mm-hmm.
Why is like message blue? Is it like a variable name, just like created at and sender ID?
That's a great question. Yeah, so all of the different colorings in VS Code are for syntax highlighting. Message, I'm not sure why it thinks that's a special value. Yeah, I think this code will work just fine. Yeah, I guess I don't know. Good question though. Let's see. Another thing that I don't think we actually talked about explicitly was that all of these different commands, they must end with a semicolon at the end of the command. And the semicolon at the end of the command is how SQL knows that the command is over. When these schemas for tables get really large, it's really kind of annoying to put them all on a single line like this if you have, say, like 50 columns in your table. And so you'll see people very commonly format them kind of like this, where each particular item in the table, each column is on its own separate line, and they're all separated with commas. And the way, again, that SQL knows that the command is over is there's this semicolon right here. For any message, I want the sender ID to be not null, that if there's a message that's been sent, then we must have the there must be a person who sent it. So I'm going to want that one to not be null. Similarly, if there's a message that's been sent, it must have some sort of text inside that message. So I'm going to have the message be not null. And then if there's a message that's been sent, it must have a particular time that it was actually created at. And so this one will also specify as not null. This not null you're seeing is a very common thing to add to make sure that your database, sometimes we'll say that it maintains integrity, that all the data that's in your database is valid data in your database. So let's save this, and let's see. I'm going to come down here and Control D to exit SQLite. And if I come back up here, I'm going to rerun SQLite on the monday.db. And I'm going to reload, so calling .read on this monday.sql file. Monday.sql, like this. And you'll see that we're getting these error messages right here. So this error on line 23, is because we've already actually created this table in the database. And so it doesn't make sense to create this table again. And notice that we did not get errors on any of these values right here. We did not get errors on them. And if we were to run select star from users again, now we have a whole bunch of duplicate users in our database that we have Trump here with user ID 1, 874, and we have Trump down here again with ID 7 and same username and same value. So there's nothing preventing us from adding these things multiple times over again. That's a potential big problem with our database. Let's see, we also got another error message, line 43. So, whoops, looks like I have all of this information down here. Forgot to comment all of that out. So that was not a valid SQL command, and so that's why we're getting error messages here. But we should have, if we were to do the select star from messages, there's nothing inside of that table right now. And so we will need to do the insert into messages, sender ID, comma, message, comma, created at, and then values. And I'm going to do put these values on their own separate line like this. There's another common pattern that you'll see people use with SQL is if you're inserting things, to put all of the columns you're inserting right here, and then all the particular values you're inserting on a separate line down below. And so I want to import, let's see, so it's sender ID, or sender ID 2, then the text was we'll change this to I am a baby for now. I'm not doing I am a baby because this single quotation mark matches up with this quotation mark. In Python, we could what's called escaping this quotation mark, letting Python know that that quotation mark is not part of the is not actually the end of the string, but actually part of the string by using a backslash. In SQL, the way you escape a string is you have two quotation marks like this. And that two quotation marks will be converted into a string that actually has just a single quotation mark inside of it. So I'm a baby, and then the timestamp. In order to specify a timestamp, you put it inside of a string like this. And I could rerun this whole command, but what I'm actually going to do now, this time I'm just going to copy and paste it, copy that and paste it down here. And you can see that because I did not have a semicolon at the end of this line, when it got to the end of that line, it didn't run the command yet. It gave me another line to type things on here. And now when I hit enter, it'll run that command. And now when I do, whoops, there it is, select star from messages. Here is the contents of the messages table. And this was the tricky part right here. This message has a single quotation mark inside of the message right here in this contraction I'm, because I put two quotation marks here. Again, that's called escaping. Are there any questions about that? Okay. This insert syntax, the reason that people commonly put it on multiple lines like this is because you can actually insert multiple things at the same time. You can insert multiple messages at the same time. So if I put a comma at the end of this parentheses right here, and now I can add another message just below. And this, this new row in this messages table, I'll have to specify these same exact columns. So I'll look down here, it should be 0, comma, I'm a baby, comma, and then let's copy and paste that big timestamp. comma, and then the next row is a 1, comma, I'm a baby, comma, and then the timestamp for that row like this. And we'll put a semicolon on that last one. Save that. Now if I copy and paste this down here, we can insert, it's inserted all 3 of these rows at the same time. So if we redo the select star from messages, we'll get this first row is inserted twice. Once because I inserted it here in the big group of messages, and once because I inserted it here. But then these 2 messages will also appear down here as well. Are there any questions about this syntax? Yeah, so if you're feeling like a little bit overwhelmed, like there's a lot going on with this SQL commands, that's sort of the right way to be feeling at this point. That if you haven't seen any of this before, it's very different than HTML, very different than Python, and so it takes a lot of getting used to be able to write these statements fluently. For your actual homework that we're going to be doing, the tables, I'll be creating these tables for you. You'll be able to use these users table and messages table. So use the schema as I'm creating it. And so it's useful to sort of understand what all of these pieces mean and why they're all here, but you're not going to have to remember like from scratch, like creating these things by yourself and what all of these, yeah, you're not going to have to add more things from scratch by yourself is the takeaway. So that said, there's a couple more complications that I want to add to the definitions of these schemas. And the first one is that this created at, that's a timestamp, but this is kind of like the ID where it's really annoying to have to specify these kind of automatically or manually every time I add it. That the computer knows what time it is every time I run an insert command. And so it would be really nice if it just automatically, whenever I run the insert command, it would tell me what the timestamp is and use that so I don't have to do it manually. And that's possible to do. The syntax is you specify a default and say default current timestamp like this. Now there's the question of, so I've changed this SQL file, this SQL file, but my database has not actually been changed. So if I were to rerun this, say, insert command, we'll just create a new one right here, insert, and take out the created at. It'll do values of, it'll be user 2, Evan again, creating his message. We'll say I'm actually a toddler. And now we're not specifying a timestamp. So what we want it to do is automatically specify this timestamp for us. But if we copy and paste this down into the SQL code right here, to see that we get this error message, this not null constraint failed, because we're trying to insert a message without specifying this timestamp. And we've never actually told the database yet that, that we want to do this default current timestamp. So one way that you might think about doing that is to, now that we've made this change up here, trying to copy and paste this into the database. And you'll see that we get this error message saying error, table messages already exists. And the principle here is that once you've created a table, you can't change the schema. And I put can't in parentheses, scare quotes, because technically it's possible that if you're really good with SQL, it's possible there are SQL commands that change it, but it's kind of difficult to do and not something that we're going to do in this class. So if you're actually wanting to create a new schema for your table, the thing to do is actually just to create an entirely new database, create an entirely new DB file. And so in order to do that, I'll specify a new file name down here. It's not monday.db, now it's monday_new.db. And I will do the .read of monday.sql, loaded all of that in. You can see it created this new database file up here. And now it's going to be okay to run this insert command like this, because this message's schema was actually created with the default current timestamp. And so now when I do select star from messages, this I'm actually a toddler message has a timestamp associated with it. So that's one schema change that I wanted to show you. The next schema change is up into this users table that we saw in this users table. How let's look at it again. If we do select star from users, here we go. But it would be really bad if our Twitter allowed many users to have the name Trump, because then we would have we wouldn't know which Trump is sending messages. And so we want the username to actually be unique to so no users can have the same username. And in SQL, the way you do that is there's let me reformat this so that every column is on its own line. That's a little bit easier to read. And now we'll add what's called another constraint on the username, and we'll add a unique constraint, unique like that. And this will tell SQL that username can't be duplicated. If we ever try to insert something with the same name twice, it'll give us that error message preventing us from doing it. So really quickly, we'll save that, come down here, quit out of SQLite 3, and we'll create a newer database like this, and we'll read monday.sql like that, and select star from users. That looks good. But now we'll see what happens when we try to insert into users with the same username. We get that error message again. And that error is good. It prevents us from adding these duplicate usernames. So this schema here for the users table and this schema here for the messages table is what we'll be using, or it's really close to what we'll be using for the assignment. On Wednesday, we'll talk about actually being able to access the information in this database from Python and being able to add things to it from within Python. And again, that's what your lab on Thursday will be about as well, is adding and inserting into the database in Python. For today, though, that's it. And that is the end of our official class. Happy to stick around and answer questions that anybody has, whether they are about the contents from today or whether they're about the homework that's due tomorrow. So feel free